Hello everybody, thanks for joining me for this last presentation. So it's been a long day, so it's tough to stay focused, but thanks for having me there. So we're going to speak about Groovy and especially the latest developments in the latest releases. And we'll also speak about the things we're working on for future versions. I'm Guillaume Laforge. I'm the project lead of the Groovy programming language. I've been working on Groovy for the past 10 years. I'm also a member of Les Cascodeurs podcast, for those who speak French. There's a recording tomorrow morning. Now I always plug that little slide every in all my talks. This is about the Groovy weekly newsletter for those who are interested in Groovy and want to get some news in their inbox every Tuesday. You can subscribe to that newsletter, and you get all the news about Groovy, Grails, Gradle, etc. So that's worth subscribing to if you want to have everything in your inbox. A summary of all the things going on in the Groovy ecosystem. So a few words about the Groovy roadmap to put everything in context. So the last stable version of Groovy is Groovy III, and we've released already 3 betas of Groovy 2.4. So we'll cover the new features of, well, the latest stable version, which is Groovy 2.3, and we'll speak about the new features in 2.4. And then, although the roadmap is not set in stone, we'll speak about what will be our focus for the upcoming releases. So let's start with Groovy 2.3. So first of all, who's a Groovy user in this audience? Okay. Majority, so that's good. Which version of Groovy are you using? Is it already 2.3? And folks using some earlier versions? Okay, so it's a split. Okay. So the first thing that I like to mention is the JDK8 support. So it's only since Groovy 2.3 that we say it's okay to use Groovy on JDK8 because before there were the thing is that there were some incompatibilities with how the JDK evolved, and for instance, how we add new methods to decorating the APIs of the JDK, and we had to introduce a couple breaking changes because of the new default methods in Java interfaces and that kind of thing. So, plus some other issues with bytecode. So this is really the first version which is officially supported for running on JDK8. And one of the key highlights of JDK8, so I did a full talk on Groovy and Java 8 JDK8 yesterday, and I'm just going to mention here the lambda expressions in Java 8 versus the Groovy closures. So just to give you 2 little examples, if you create a range of ints and you want to iterate over that using lambda expressions, this looks like the Groovy closures without the curly braces. So this is how you will iterate over all the numbers and print them. Same thing here with if you want to to go through all the lines of a file, transform the lines into uppercase and print the result. One of the things we worked on in Groovy 2.3 was the ability to do the same kind of coercion mechanism, which transforms a lambda expression into a functional interface. So what we do here is that you can actually use Groovy closures wherever a lambda expression is expected. So you can already use the Java Stream APIs or any API leveraging lambda expressions. Wherever there's a functional interface, basically, you can use Groovy closures. And we go slightly beyond in the sense that lambda expressions can be coerced into functional interfaces, but here we go slightly beyond with Groovy closures because it's what we call some types, which is a single abstract method types. So it also works with abstract classes with a single method being abstract. So this works also not just for functional interfaces, but as well for those kind of classes. So we're ready for all those API using the stream API, using the Lambda expression, sorry. Another, so we'll come back to the topic of Java 8, the new syntax construct, because we are going to address that in the next versions of Groovy. So I'll come back to it a little bit later. Let's speak about traits. So traits introduced in Groovy III are a bit like the default methods of Java 8 interfaces. So you can have methods with a body, but it goes a bit beyond. So what's nice with traits is it's an elegant way of composing behavior without avoiding the usual diamond inheritance problem. So you can inherit from various traits at the same time and inherit some behavior. That's a method with a body. By behavior, I mean that. Traits can also be stateful, so you can use Groovy properties in the declaration of your traits. It's compatible with the static type checking support and the static compilation support, so it works very well if you use those in your Groovy classes. And another, so it's a sub-bullet, but it's important that all those methods that we add and we inject into the class which are implementing traits, is that those methods are also available, viewable or visible from Java classes. So it's not a dynamic feature from Groovy by essence, by nature. Is a dynamic language, so although we added many features related to static typing, etc., and static compilation, we always try to be as friendly with Java as possible, and that's one of the things we did, that it's working nicely as well with Java. So if you have, what I mean by that, again, is that if you have a class implementing a trait, when you use that class from a Java class, those methods are obviously available. And we can implement traits at runtime. So let's see that in action. So here I'm going to define a simple trait. This is flying ability, so the ability to fly. So this is a bit like a class definition or interface definition with methods, with method bodies. So the concept is quite important. So we implemented that in the form of AST transformations. We could have used an annotation, like for some other features of the Groovy language. But it's such a concept which is part of the object orientation of the language that we felt that we needed a new keyword for that. Just like we have a keyword, for class, for interface, for @interface, for annotations, for enum, etc. We felt that we needed to have a proper keyword for the purpose of implementing traits, because that's part of our object orientation, of the story about object orientation. Then a class can implement a trait, and we use implements there because we can implement several traits, whereas the extends keyword is just for extending one class. So it makes sense to use implements. We instantiate the bird class. Then with that bird instance, the variable, you can call fly, which is coming from the trait. Next, excuse me. Next example is about being stateful. So in Groovy, when you have properties, you can write, a class person string name, for instance. So string name is a Groovy property. So the Groovy compiler will generate the usual getter and setter, etc. when you implement that trait. So here, our bird class implements the named trait, and then we can. So we implement the trait. We can also use the named argument constructor from Groovy. So it's calling the usual default constructor, then in turn calling the setter method. And we can also use the property notation for accessing that property, just as if the name property was implemented inside the bird class. Speaking about inheritance, so a trait can extend another trait and implement interfaces as well. So in that example here, I'm just extending the trait, so I don't implement an interface, but it's possible to do that. So I have a named trait from earlier. The flying ability trait this time is extending the named trait. So when you implement the flying ability trait, you'll have both the fly method and the named the name property, and that's why here this name placeholder in the G string, in the interpolated string, is going to reference, of course, the name coming from the trait, which will be inside the bird class that implements the trait. So again, we can use the name constructor. We can access both the name and the fly method because we inherit that from the two traits. Another interesting case is what happens when there are conflicts. When there are conflicts, so here I have the kite surfer and the web surfer traits. Both have a surf method. So what happens when we implement two traits? And something which is interesting in that example as well is the fact that you notice I extend a class, but I inherit some behavior from those two traits. So you see extending a class and implementing two traits at the same time. So what's happening there? So it's a convention. We could have chosen to throw a compilation error, for instance, but we went with saying that the rule is the last declared trait wins. So in this case, the last trait defined in the implements clause is the web surfer. So the surf method is going to be coming from the web surfer trait, and this is why this assert is going to show the web string. If you wanted to have the reverse situation, you would just reverse the order of the web surfer and kite surfer, and then the surf method will return kite because that's the one coming from the kite surfer from above. But if you want to be explicit rather than relying on that convention, you can also go with, so it's like the Java 8 syntax actually. You can go with that syntax here. So you override surf in your class directly, and you are explicit because you say, okay, that's the surf method from kite surfer. So kite surfer dot super surf will call the one from the super trait, which is kite surfer. So you can be explicit. Little remark. So I mean, we said that the last declared trait wins, but of course, if you override the method in your class, that's the one which takes precedence. Those bubbles are useful if I forget something. So here we're going to speak about runtime implementation of traits. So this one is not a runtime implementation, but I'm starting with that before going to the runtime implementation one. Sometimes, so here in this case, so you know most animals don't really have a name, but for instance our pets, you can give them a name. So you might have just one instance or some instances which are named animals. So in this example, using compile time implementation, compile time traits, you have just a named animal class implementing named, and you know there's nothing really useful into that named animal because it's really just implementing the trait. So there's not much added value to that. So again, you can call name Felix, na.name, etc. So that's just like the examples we've seen before. But you can decide on a per instance basis to have one animal instance that implements that named trait. So this is what we are going to, so instead of having an artificial way of saying, okay, I just want this named, I introduce this named animal just for the purpose of having some instances which are named. So instead you can do runtime implementation of traits by saying new animal as named. So we're using the as operator, which is often used for coercion in Groovy. And this animal will be named, and then you're able to say na.name, etc. So this is for calling the setter, and here for calling the getter. I thought I had a bubble about that. So the sole little gotcha to be aware of is in terms of implementation, the resulting NA object here is actually not, so it's instance of named, the trait, and the underlying interface implementation. But it's not instance of animal, so this might be surprising, but that's something to be aware of. You can, so in the first example, we used just we used as named, but what happens if you want to use, to implement several traits at the same time? So we cannot use the as operator, because it just takes one class, right, on the right-hand side of the operator. So instead, there's a new method on all objects, which is with traits, which allows you to say, okay, I want an animal that's got a name and that quacks. Okay, so you can't use as for that purpose. So you have to use this with traits method. So this is gdkdoc, which quacks. A new whoops, sorry, I don't know where it's highlighted. A new feature. So actually, it's in. I should have put that in the 2.4 section. But anyway, so this is not yet implemented, but will be coming in Groovy 2.4. Should have moved that later on in the presentation. Sometimes you want traits to constrain to what the traits can be applied. So you might want some kind of component decorator to be applied only to components, but you don't want it to be applied to anything. And there's not really a way to say, other than with this new mechanism in Groovy 2.4, in the upcoming Groovy 2.4, to say, okay, I want to say, okay, I want to decorate my component. And here, just for logging a method call to the do something action, to the do something method. So I can restrict and say, okay, at self-type component, this trait will be applied only on components or a child of components. So this means that this trait will be you'll be able to apply it only to component or a subclass of components. So this is only 2.4, so I'll need to fix that in my slides. Next, we have new code transformations, new AST transformations. So there's the new TailRecursive annotation that rewrites TailRecursive friendly methods in a serial fashion. So instead of blowing the stack with a big Stack Overflow error, because when you call factorial 1000, you'll get a Stack Overflow error. What we do is that we annotate the method with @TailRecursive, and if the method is really TailRecursive, that is, if the last evaluated expression is actually a recursive call to itself, then the code can be rewritten serially rather than doing this, bubble up of the stack, generating the Stack Overflow error. So the little drawback, I would say, the downside is that you might have to somehow rewrite the algorithm slightly to be tail recursion friendly, because if I did a naive implementation of factorial, I would have done if blah 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 else n times factorial n minus 1. But if you do n times factorial n minus 1, it's not a tail recursive call, because the last expression which is evaluated, it's a multiplication by n and factorial. So this is not tail recursive friendly. So here instead I slightly rewrote my example to use an accumulator so that I can serialize somehow the calls to factorial. So if you do, factorial 1000 in Java with the naive implementation, obviously you'd get a Stack Overflow error. The same thing with Groovy without TailRecursive, but with TailRecursive, if you've got recursive algorithms, you can avoid those kind of errors for big numbers, for instance. We have an Apptsortable transformation. So this one is going to make the class comparable and provide and chain several comparators, a comparator for the last name, a comparator for first name, a comparator for int, and combine them together in that order, so as to be able to have a nice comparison. First we compare by last name, then we compare by first name, etc., and by age. The transformation also adds, so I don't remember by heart the name of the method, but it's compare by last name or comparator by last name or something like that. So it adds also new methods. So if you want to retrieve the comparator for each field, you can do that. And also, I think I've got another little bubble. You can also specify, so if you do Apptsortable, parents, includes and excludes, you can say, okay, these properties I want to include or exclude them. So perhaps you might want to exclude the age or just include the last name or something like that. So you have some control, some parameter for these annotations, which provide more control over how you want these to be sorted. So this is interesting for when you've got UIs, etc., and you want to have an alphabetical order of the persons, etc. Another one, that's AdBuilder. So it's not the usual Groovy builders like Markup builder, JSON builder, XML builder, etc., but it's really the builder for fluent interfaces. So when you annotate a class with AdBuilder, it's going to generate this kind of code, which is so there are different implementation strategies actually. This one is the default strategy. So it's going to create some builder objects on which you're going to be able to call first name, Robert, last name, blah blah blah, age, etc. So that the methods are chained, returning ultimately the person. So there are other implementation strategies that you can use for that if you want a builder which is external to the person class, etc. So you have some choice depending on how you want to implement Fluent APIs. But it's, I mean, we see more and more of those kind of Fluent APIs in most frameworks these days. And that makes the code much more streamlined again, because our usual mantra for Groovy and in particular for AST transformation is that we want the compiler to do the job for you of implementing certain patterns. So if you want to implement that Fluent API kind of pattern, that's the Groovy compiler that's going to generate the code for you, the boilerplate code, so that you don't have to write it yourself. So there are, I think, 3-4 different strategies in terms of implementation. There's one which is with chained setters. So that setters, so set first name returns the person, set last name returns the person again, etc. So there are different implementations. So it's up to your own taste and how you want that to be used in your code base. We have base script, so it's an improvement, it's not new AST transformation. Sometimes in your scripts, you want to have some base script class that is common to the various scripts that you are using. So you might want to have some pseudo global methods that you want to be available in your script, or you want to have some constants available, etc. So you can use base script. So the improvement here is that you can use base script on import and package, although before it was using a local variable that you annotated with that base script. So this is well, a new way of doing that. And also notice, for those who don't know, that you can also hide that if you use compiler customizers, compilation customizers, so that you don't have to repeat for each and every script that you want to use this particular base script class. So you can hide that somehow by configuring the compiler. It can be useful. Hup. So this is the base class. Another improvement related to base scripts is the ability to when you write a script, it's a freestanding list of statements without a class structure around it. So you don't have to say, class my script and implement the run method, etc. But the body of the script. So under the hood, we actually do generate a script class. So it's a child of the Groovy length script class. You have the body of the script, which is actually put in a run method. That's how we transform a script into an actual Java class, if you will. And something that happens is that sometimes you want things to be executed before or after. So it's a bit like, in JUnit when you want to do a before-after class on that kind of things, or setup, cleanup, and that kind of pre and post treatment. So what you can actually do is that, so the scripts still have to implement the run method, but you can be explicit here by implementing the run method yourself, but creating a new abstract method, which will be the one which will get the statements of the scripts. So here, my script, so here I use again the base script trick. So when I do println hello, so the println hello statement will be, will be put into the internal run method body that the Groovy compiler will generate. And then before will be called before, then your own statement in your script, and then the after call. So that's nice if you have to do stuff before and after the execution of a script. Hup. Now in terms of APIs, in JDK7 and also in JDK8 actually, because it's been refined thanks to the Lambda expressions, the stream API. Usually when you use those methods with reader, each line, each file, recurse, etc., or read lines, that's used. It was only on Java IO file, but with the JDK7 path class, etc., all the new IO2 stuff, and all the refinements in JDK8, we also wanted to have the same kind of API, same decorations that you had through the Groovy GDK, like with reader, each line, etc. We wanted to have the same feeling when you use those path objects that you had with the file objects. So we enriched the path class, the files class, etc., with certain methods, just like we did with files. So it looks, coherent. That's the same usual methods, but it works now on path as well. And there are plenty of useful utility methods, like on the files class with static methods, and we could also add those ones on top of path, like rename, move, whatever. We could add that directly rather than using files dot rename and you pass the path, etc. So that we have some further ideas of things we'd like to improve for the JDK7 and 8 improvements to the new IO2 module, the APIs. Okay, so this is Jason, for those who know the reference, Jason movie. In Groovy III, we totally rewrote the JSON parser and the JSON builder in order to increase their performance. So it's been contributed by Rick Hightower, who did a new implementation in his framework called Boon. So it's not very well known, but he did really a great job at fine-tuning how fast you can make JSON parsing and building JSON. And he wrote, so in the link below the graph, he made a comparison of the Boon implementation, which is now in the Groovy code base, compared to Jackson and JSON or JSON, I don't know how to say it, the Google library for JSON. And the parsing speed is consistently 2-3 times faster with the Groovy JSON support compared to Jackson or JSON. So it's the really super fast JSON parser. And there are new modes for parsing, so I won't really go into the details of the various modes. So some modes are better for small payloads, some are better for bigger payloads, bigger JSON document. And there's one which is interesting, it's the lax, like in relax. The lax mode, so instead of just saying new JSON slopper, you can say new JSON slopper set type relaxed. Lax, and then you're able to because so far the Groovy JSON parser was really strict in terms of, you know, the JSON content has to follow the RFC and the specification of JSON, so it wouldn't allow comments, it wouldn't allow non-quoted keys, etc. So this relax mode supports comments like this. / kind of commands. It supports the pound style commands. You can omit the quotes around the keys. You can use both single quotes and double quotes for the keys, although in JSON normally that's just double quotes. And also things like missing comma. So here normally you would have had to have a comma at the end here of this object, JSON object, environment, production, comma, server, :5. So there should be a comma there. So it's pretty tolerant if there are problems or errors in the JSON content. It's been one of the frequently requested feature from people who wanted to use JSON for configuration files. When you do configuration files, sometimes you like to put commands to say, okay, this part is about configuring something, this other part is about configuring something else. And so we had quite a few times the request to get the ability at least to support commands and then avoiding quotes for keys, etc. So it's a new parsing mode. We have a new template engine called the Markup template engine. So it's inspired also by the Markup builder you're certainly familiar with if you're familiar with Groovy. It's super fast and efficient because it leverages the static compilation ability, the static type checking extensions, etc. It works nicely for internationalization, so it's, you know, the same approach as with bundles, where you use a special file name for your bundles for a different locale. You can define also custom base template classes if you want to have methods which are common across templates. You can do includes, etc. And it's also in Spring Boot. So you can use that from Spring Boot if you like this, excuse me, this syntax. So more concretely, the idea is to have something which looks like our Markup builder stuff. So let's say you have, you're going to create a cars tag and you're going to iterate over all the cars of some model coming from the model. And then for each car, you're going to create a new car tag with some attributes, the make and the name. So this is your template. Then you pass a model into, you feed that model into your template, and then you're going to have that kind of output. Okay? So how do you do that? Excuse me again. How do you do that? So you're going to instantiate the Markup template engine, you're going to create the template. So this is not the same example as the previous slide, but you get the idea. It's going to create the template, then you feed the model through the make method, and it's making the template with those values, and then you can, you know, output that to the servlet output or whatever. So this is how it's working. There are some interesting features as well, like includes. So you can include other templates, you can include raw content, unescaped content, or you can also include escaped content if you want to escape things like the less than sign and things like that. So you can have automatic escaping going on. And if you want, you can also use another method than create template. And there's another approach as well, so that your templates are actually type checked. So let's say you make a mistake in a variable that you want to use in your template. So in my previous template, you had the cars variable in the template, and you want, so let's say you make a typo and you write cars with a Z instead of a Z at the end instead of an S, then you would have a compilation error when your template is being compiled, because it's going to tell you, hey, I don't know about that variable, I don't know where it's coming from. And so there's actually two ways for that. So either you use the new method, create type checked model template. So it's a Spring-friendly name, you know, long method names or class names. Or the other approach is, so notice that you have to define the types as well of the variables which are being used. So here you can say, okay, the cars is a list of car. Or the other approach is you can define the types in the template itself. So there are two modes. And if you do that, you can actually use the create template method as usual without having to use the special create type checked model template. And then you have the nice compilation errors, etc. And just for the record, later on I'll be mentioning and showing the new Groovy website we're working on, and we actually used the Markup template engine for the purpose of the new website to generate the static website, the new static website. So speaking of website and documentation, so groovydoc looked like the old Java doc from JDK3, Java, I don't remember, 1, 2, 1, 3, etc. So it didn't have the nice style of the newer Javadoc style. So we have a new style sheet for GroovyDoc. So if you use GroovyDoc yourself, you will notice if you use Groovy II, 3, and beyond that you can you will benefit from that nicer skin. So this is the framed version. This is the one with just showing one class in particular. We also apply the same style sheet to the GDK documentation. So that's the documentation for all the methods that we add to collections, files, etc., decorating the JDK classes. So you have the same style. So if you want to find all the methods added to I don't know, to Java IO buffer reader, etc., you can view that with the same syntax as the Javadoc, well, not syntax but style as the new GroovyDoc style. And speaking of which, the brand new documentation we've been working on, so it's based on ASCII Doctor actually, and integrated in the new website. So we used ASCII Doctor for the new documentation, which will be replacing the existing wiki that we have at Codehouse, where Groovy is hosted. What we really wanted to do here with the new documentation is that we wanted to have what I call executable documentation. So every time you're going, no, I don't have a bubble for that. Every time you have, like at the bottom there, or every time you've got a snippet of code in the documentation, it's actually a bit of code which is extracted from special test cases. So all the code snippets that you find in the new Groovy documentation is actually runnable code, basically, because we actually run all the tests, and we can really only generate the documentation if all the tests are passing. So all the snippets of code are working properly. And let's say someone writes a new feature for Groovy or changes something somewhere in the code base. If you actually make a mistake somewhere, it's going to break potentially the tests which are included in the documentation. So the guy will have to fix the test so that the documentation generates nicely and the build is successful. So that was our solution to avoid, because if you look at the old Groovy documentation, the current but soon to be old documentation, there are some places in the current Groovy documentation where there are some mistakes in some pages because it's not been updated accordingly when we were making changes to the code base. So there might be certain things here and there in the documentation which are broken if you're trying to reuse that in your code. So this is the ASCII Doctor based new documentation, and we also try to follow the same kind of styling as the groovydoc and Groovy GDK documentation. And I also speak about the new website later on, where we actually integrate those new APIs, documentation, and the new documentation itself. Now on to Groovy 2.4. So there was one feature I already mentioned that I should have moved there. That's the self-type annotation for traits. So it's there now in Groovy 2.4. So let's continue first with the new website. So instead of groovy.codehouse.org, you'll be able to go to groovy-lang.org, and you'll see something like that. So this is the front page of the new website. You'll find also the various pages, and notice that so it's probably a little bit small here, but there's an improve this doc button. And it's actually, so the website, as I mentioned, is built with the Markup template engine. So it's using a friendly Markup builder-like syntax. And if you notice something, like a typo in the website, or you want to add, so there are sections like if you run a Groovy user group, you might want to be added to the list of user groups. So you can click on that button and you'll be redirected to GitHub because it's in our Groovy repository on GitHub. So you can help us improve the website and add new sections or fix typos or that kind of things. So you can help with the documentation. The website, and for the documentation I'll try to add also such a similar button in the ASCII Doctor based documentation as well. I'll try to add that. Something Cedric was there, worked on is the Android support. So if you use Groovy 2.4, Beta 1, 2, 3, and beyond, you'll be able to write Android applications in Groovy. And tomorrow at 10:45, Cedric will do a presentation on Groovy on Android. So if you're interested in mobile development, in particular on Android, you'll be able to see how concise and productive you can be when working with Android from Groovy. And an example is the New York Times, who are actually rewriting their Android application using Groovy. So they wanted to have something more responsive and have code which is easier to read and maintain, and that's why they decided to go with Groovy for the language and RxJava for the reactive aspects. And they wrote a blog post about that if you're interested in reading more about the details. And just to highlight a couple of things, so there are some demo applications as well that you might want to have a look at if you want to see how writing an application for Android on Groovy looks like. And yeah, I thought I had yeah, well, never mind. So Cedric will detail that tomorrow anyway. In the blog post that I mentioned here, they show, for instance, how you can get rid of anonymous inner classes, which somehow plague the development of Android application, because you have to use anonymous inner classes all the time, everywhere, using the many APIs of Android. And they explain how it's much shorter when you use Groovy closures instead of anonymous inner classes. So you can read the details of there. And they also like the fact that with static compilation, it's as fast as Java, so you can use Groovy confidently in terms of performance, and it can be as type safe as Java itself, or even more actually in Groovy, thanks to static type checking as well. Okay, so something we're looking into right now is the ability to add macros to Groovy. So macros, a bit like in the sense of Lisp macros, not macros like in the C days. So it's a way of simplifying the authoring of AST transformations. Currently, if you write AST transformations, for example, if you want to, so what this one is doing, if you want to return a new some cool class which takes an XYZ parameter. So you see that I have to mentally try to parse the API usage because the API, although we like to reduce boilerplate in Groovy for the internal API for the ASTs, the abstract syntax tree, the API is quite verbose it's originally a Java API, and we want to find a way to simplify building, changing, updating, modifying, creating new bits of AST. So one of the thinking is to be able to write something like that. So you might have a macro representing some variable, some value, etc., and being able to write more or less the pseudocode that you actually want the AST transformation to generate. So here, new some code class, and then you're passing the value coming, let's say, from another macro that generated some variable, some value here. So this is the kind of things we are looking into. And Cedric's been working, for instance, on also AST pattern matching, so that you can find a particular piece of AST in the whole AST of a class to say, okay, I want to apply something at a certain point if it matches a certain pattern of AST, if it's a the example we often take is the factorization when you do A times B and A times C, and you want to add them, you can do A times B plus C instead. So you want to refactor your code somehow, and you could match the pattern and try to do the factorization with an AST transformation to improve, the speed of the code or for some other purpose. So this is something that's being worked on. It's not yet, again, set in stone. So if you have some feedback as well about that, don't hesitate to bring that to our attention. And then I'll finish with Groovy 3. So Groovy 3, don't really take that. So although I put Groovy 3 in the roadmap slide in the introduction, Groovy 3 is kind of our long-term goal evolution of Groovy. So it's not necessarily the next version after 2.4. There may be a 2.5 or 2.6. Sometimes we introduce new versions in between. But the idea here is, so there are actually three key topics. We are going to rewrite the grammar of the language. So when I say rewriting the grammar, it doesn't mean we are going to change the syntax of Groovy. So it's not going to break your code. Excuse me. What we are going to do is to actually update the parser to use a newer version of AdBuilder, which is the tool we use for generating for dealing with the parsing of the Groovy syntax. It's got some interesting advantages. Historically, the syntax of the grammar, the grammar has been coming or has been evolved out of a Java grammar. So that's why the grammar of Java and Groovy are pretty similar. So we can start with a clean slate rather than a hacked Java grammar. What's good as well is that Ontler is better at dealing with production rule ambiguities, because as soon as you want to touch the Groovy grammar, which is quite complex, that's the Java grammar plus the Groovy special bits. As soon as you're trying to make some modifications, you end up with complicated disambiguation rules, semantic rules, etc. So it's really a nightmare as soon as you want to do a little addition or change into the grammar. So certain things are not very hard. For example, when I added the trait keyword in the grammar, that wasn't hard, but some other changes are more complicated. And when you look at the Java 8 features, in terms of syntax constructs, some might be tricky to support in the Groovy grammar. So that's why we are working on that. And actually, Google Summer of Code did the first pass. So we have a first pass out of the new grammar based on Ontler v4, but we need to finish the work because it's not covering all the cases. And this new grammar is also important because we'll need to have an easier way to introduce those new Java 8 language constructs. So this is the point of that part. So we, yesterday in my presentation and a tiny bit in introduction about Groovy II/III and lambda expressions from Java 8. There are new things in Java 8 in terms of syntax. So you've got lambda expressions, you've got method references, you've got default and static methods in interfaces, you've got new APIs. So new APIs are okay because you can just use them from Groovy, there's no problem. But the bits which are painful is more the syntax. You can also put annotations on types everywhere. You see the class type somewhere, you're able to put annotations everywhere. So you'll be able to litter your code with annotations everywhere. And there's also repeating annotations. That's the ability to say, I don't know, repeat twice the same annotation on something, which is normally not allowed before Java 8. So we are going to have to support that. We also need to think about the redundancy. So for instance, Groovy has closures, so Java 8 has lambdas. We had our own method pointers, our method closures, which are similar to method references, but now you have two different syntaxes. So what should we do? Should we support, in addition, the Java 8 syntax or not? Or deprecate the existing one and move to the Java 8 syntax, or support both? The problem, if you support both syntaxes for things which are common between the two, is that developers will now think, okay, so I can use a method closure or I can use a method reference. So when should I use the one or the other? Or when should I use a lambda expression, or when should I use a closure? So we have to make a decision. We have to make some calls on certain of these things. I mean, there are things which are easy to decide, like default methods in interfaces. It's core to how interfaces work now in Java 8, so we have to support that. Some of the syntax constructs are really easy to decide what we want to do about them. We need to support them. But for lambda expressions, since closures have the same coercion mechanism, and even goes beyond the coercion provided by the JDK, it probably doesn't make sense to support lambda expression. I don't know. So it's also up to you to help us make those decisions if you've got a strong opinion on either possibilities. And the other big topic, so it's something we've been saying for years and years. We really want to rework the runtime of Groovy, the Meta Object Protocol. That's the MOP, with the MOP 2, the second version of the MOP. So in Groovy 2 and beyond, we studied leveraging the invoke dynamic instruction and the underlying APIs. To have Java-like performance, even for dynamic code, without going through the static static compilation, etc. We also want to take a chance at making homogenizing the APIs for doing metaprogramming, because there have been many layers of metaprogramming tricks on top of each other, and there are some corner cases or inconsistencies. Like, for instance, invoke method doesn't isn't invoked at the same time if you've used the invoke method on Groovy object, from Groovy object, or through expanded meta class, etc. So we have to fix some inconsistencies. We also have this idea of a notion of a realm where you want to say, okay, you do metaprogramming in that area, but you want to shield users from being affected by other metaprogramming changes happening on the types that you are using in your API, etc. So we try to segregate or protect and shield from monkey patching, people hijacking your code somehow without you knowing about it. And we're also thinking of making, so you know in Groovy you can access private fields called private methods very easily. You just call them without having to use, you know, reflection, set accessible, etc. So what we're thinking is that by default we won't be allowing access to private stuff, but we'll provide a special notation for really accessing private stuff. So in that case, you have to be explicit if you want to use private stuff. And one of the good signs of having private visibility, being able to call private stuff, is that for when you want to test code which is not in your control, if you cannot put things public, or you want to, you know, test private methods, you're still able to do that, but with a spatial syntax. That's our current thinking about that topic. Well, a very, very short summary. Groovy rocks the JVM since 2003 already, right? So thanks a lot for your attention, and I'm happy to answer 2-3 questions. We still have 5 minutes for questions. So anyone who's got a question in the audience? I don't see any hands being raised. Oh, there, yeah. And with the light, I don't see you. Yeah.
So actually, yeah, great presentation.
Thank you.
To the new Groovy releases. With Antler 4, will it be easier to interact with something like comments or so? Because I'm also generating code again from AST, and with Antler 4, this is incredibly easy compared to the token stuff.
So will it be easier when moving to Antler 4 to access things like comments, etc.? So I think the current first path of our Google Summer of Code student didn't take care of comments, but it's something we might be adding because it's interesting, obviously. So that might be something that's going to be added. So we'll need, you know, a new AST node for representing that, and etc. But yeah, it's definitely a possibility. So don't hesitate to you know, mention that on the mailing list, saying, "Oh, hey, with the new grammar, I'd like to be able to do this and that," and we'll try to. Yeah, it's much easier with Antler 4 in particular, 3 and 4. And the first improvements came with 3 already. Yeah. Any other question? No. So thanks a lot for your attention.